Okay, you guys have done exponents such as 2 to the 5th, which was, what did that 5 mean again? 2 times 2 times 2 times 2 times 2. 5 of them turned out to be 32. Now we did some exponents. There are even some formulas that have some exponents in them. That was kind of nice. Now we're going to do some rules that deal with exponents. Now, I'm going to change this to a number. So we have something like x to the 5th, because it could be any number out there. And see what happens when we take x to the 5th and we times it by x squared. And remember what this is. This is 5 of them put together. This guy is 2 of them put together. How many do we have then? 1, 2, 3, 4, 5, 6, 7 of them. So we'd write that like that. We're timesing these over here, and we ended up 5 and 2 gave us it. Let's try another one. X to the 3rd times x to the 7th. Well, that's x to the 3rd. And 1, 2, 3, 4, 5, 6, 7. 3, 7. That's 10. About this time, you see a pattern. Whatever this guy is and that guy, if these are the exact same, so we can combine and say they're all together into one thing, these two exponents will add. While these guys are multiplying. So if we have x to the 9th times x to the 15th, that's going to be 9 plus 15, x to the 24. Notice that will work with the number 2, the number 7, the number 8, anything for x. You could put an m here, m to the 5th times m to the 18th. That's going to equal m to the 23rd power. 7 cubed times 7 to the 4th. It's going to be 7 to the 7th. Test that out on your calculator, see if it really works. Take a 7 cubed times the 7 to the 4th, and then separately type in 7 to the 7th to see if that actually works. You'll find out it does. Works for any number here at all, which is pretty cool. So we're going to write this pattern. If I have x to the m times an x to the n, an x to the n plus n. You add exponents when multiplying. Multiplying, add exponents. You have to multiply the same base there in order to get that to work. Okay, let's try the next rule. See what happens when you take x squared and take that cubed. This means we have x squared times x squared times x squared. Well, by that first rule, we have 2 plus 2 plus 2 is 6. 2 and a 3 gives us a 6. Let's try another one. X to the 7th squared. It's going to be x to the 7th times x to the 7th. According to that first rule, 7 and 7 is 14. Any idea what happens there? We have an exponent. When you're raising this to an exponent, you get multiplication that happens. So 2 cubed to the 7th power. It's going to be 2 to the 21st. These exponents will multiply. That's what we just came up with. If we want to write it as a pattern, we go over here and we say, okay, any number, we don't know what number it is, if it's raised to one power and that whole thing gets raised to another power. So this is how it's kind of written in the book, even though that looks a little bit odd. I kind of like thinking about it like that. You're welcome to do it either way. So if your exponent and you're raising it to a power, that means you multiply. All righty. Let's try another one. b to the 7th divided. So instead of multiplying like we did over here, we're going to divide b squared. Okay. See what happens with those if we can simplify those at all. This is 7. 1, 2, 3, 4, 5, 6, 7. Good. Divided by 2 of them. Multiplication, division. They cancel. 1, 2, 3, 4, 5 of them left. Ooh. See if you picked up on the pattern. We have x to the 6th over x to the 4th. What do you think it'll be? Based on this, kind of did a subtraction thing over there, and we got x squared. That's exactly what happens. When you're multiplying, you end up adding. If you go the other direction, there you go. So that becomes the rule. And you can try it again if you'd like. Take 2 to the 16th power and divide it by 2 to the 13th power. 16 minus 13 is 3. Now notice the answer is not 3, just the exponent on the 2. This says we have 16 2's all timesing together. We divided off 13 of those 2's. And so we have 3 of them left. So that's what's kind of going on there. However, this creates kind of an issue. We've got this great slick way of taking care and simplifying those so we don't have to like write them all out and punch them into the calculator and see what it works. We've got kind of a snappy way of doing this. However, you remember back when we did arithmetic with just numbers and we talked about, well, that a negative number may or may not like really exist. Have you ever seen like -5 trees in the forest? It doesn't make sense. -7 cars in a parking lot. Doesn't make sense. We've just started subtracting with exponents, which means we might end up with something odd. I'll show you what I mean. Let's take this problem right here. And so 7 minus 2 is 5. What if we switched it over? 2 minus 7 is a -5. Now, if you remember what an exponent is, this is telling you how many b's are timesing together. This says, well, we have 7 b's timesing together down here. Have you ever seen b times by itself -5 times? Doesn't make any sense. How do you have a b and a b and a b -5 times? It's a good point, but let's recall what this negative means. Other direction. What is the other direction when it comes to multiplication? The other direction is division, and that's exactly what happens. Let's look at this in slow motion. You have b squared on top, and that on the bottom. These two cancel, still leaves a 1 up here. So that means that this and this must be the same thing. B to the -5th power means you're dividing by b 5 times. And that's what a negative exponent means. It has to be that. So let's do one with, so if you have x to the -7th power, all that means is that you're dividing by x 7 times. Notice it's -7, x to the 7th. That's what a negative exponent does. It means you're then dividing. Now, you guys have done some scientific notation. Perhaps you've run into it, and you have something like 5 times 10 to the -8th power. It just means you've divided by 10 8 times, and that's exactly the connection we're going for. That a negative exponent here just means it's divided down there. Let's write that over here. So if we have x to the -n power, that'll be the rule that you'll use right there. So, there's another one that's kind of interesting that not everybody is okay with. So you'll have to think about this one as we do it. We're going to look at what any number to the 0 power may be. You're like, oh, easy, that's 0. Not so fast, not so fast. Let's look at it for a minute. Let's do a couple that are nice. X to the 5th over x cubed. Which rule? Read this one right here. 5 minus 3 gives us 2. So following that same rule, what if I did x to the 5th over x to the 5th? It's x to what power? 5 minus 5 is 0. Now you're like, oh, well, don't do that. What's anything divided by itself? It's 1. Ooh, should make you think. Anything to the 0 power means that we have times it by something, and then we've divided off by that exact same thing. We've gotten rid of all the times it's timesing itself. That's why we're left with 1. Now, you should give this a try in your calculator. Take 7, and you should have your little x to the y button to the 0 power. Take out your calculator, punch it in, 7 to the 0 power, and you will get 1. Take 8 to the 0 power. You'll get 1. 19 to the 0 power is 1. And they're all 1. I'm going to show you this in one more way. Make sure we can do it. Let's take the number 2 and look at a bunch of powers of it. 2 to the 3rd power. 8. That's 2 times 2 times 2. 2 to the 2nd power, 2 squared is 4. 2 to the 1 power, that's just 2. We'll come back to that guy in a minute. So negative exponent, remember what it does? It says it's 1 over 2 to that power. So this is 1 over 2, 1/2. Go ahead and try that in your calculator. 2 to the negative 1 power. Make sure you get 0.5 coming out of there. Change it into a fraction, see 1/2. To the negative 2 is 1 over 2 squared. It's 1/4. 2 to the negative 3, 1/8. An interesting side note. You guys have a button on your calculator that has x to the negative 1. Some of you guys don't have that button, but you have this button, where you take whatever number you had and you flip it over. These two are the same thing. If you take a negative 1 power, you're putting it on the bottom with a 1, that's the same thing as this. This is the reciprocal button. You can just take the number 5 and you hit the button and you'll get 1/5 or 0.2. Hit it again and it'll flip it back to 5. And it just keeps flipping it back and forth. Okay. Well, let's look at what happens. The pattern. If I take away a 2, notice each one of these I'm dividing by 2. And I keep doing it. So there's only one number that actually fits in that pattern. And it's the number 1. Anything to the 0 power is 1, which makes some of the problems you're going to run into relatively easy. Well, let's write this over here as a rule. Anything to the 0 power is 1. So, I'm going to give you a really tough problem. 3x to the 7th, all to the 4th power, all to the 0th. Anything to the 0th power equals 1. Let's do some of these problems. It'll be a little bit, let's do that one without that 0 there. Now, it's saying everything in here is to the 4th power. So 3 to the 4th power. 3 times 3 times 3 times 3, you should get an 81. 3 times 3 is 9, times 3 is 27. 27 times 3 is where we get the 81. Now, what happens here? X to the 7th to the 4th. Which rule is that going to go under? It's going to go under that one right there. So we have x to the 28th. Notice we did 3 to the 4th power. Here we didn't do 7 times 7 times 7 times 7. We had to use the rule. This is x to the 7th 4 times. 2x to the 5th times 3x to the 19th power. The 2 and the 3 are fine. That's a 6. X to the 5th and x to the 19th. Look up there, top row, and you have the rule where, 5 plus 19 is 24th. Let's try one more that's a little bit tougher. Okay, 2 and 8. reduced to 1 over 4. And we look at this guy. X cubed over x to the negative 7. If you're using this rule right here, you're going to take 3, subtract a negative 7. It's not 4. 3 minus a minus 7 is 10. That may take a little bit of getting used to. So as you practice these, you may need to ask a few questions. That's perfectly all right. Yeah, let's try one more. Okay, so we have 5x to the 7th times 3x to the 5th all squared. Now we got to take care of this. The squared goes in here and that becomes a 9x to the negative 10. Sure you're okay with that. We took 3 squared, that's 3 times 3, but this one followed this rule right there. So we're taking that times 5x to the 7th. So 5 times 9 is 45. That wasn't tough. X to the 7th, x to the negative 10. We're going to be up there at that top rule. So we have 7 plus a negative 10. It's a negative 3. Oh, but what does that mean? We're right there at this rule right here. We get 45. This guy gets down on the bottom as an x to the 3rd.